Okay, here's example number 7, where we need to give an equation that represents this graph of a logarithmic function. Remembering that our transformations of log functions can include an a value for a vertical stretch of compression, a k value for a horizontal stretch of compression, a d value for a horizontal translation left or right, and a c value for a translation up or down. I've also sketched in here in blue a graph of the function y equals log of x. That's our base function that we're transforming to give the one that we see in the picture here. So one thing we can see off the bat, and one transformation we can find quite easily, is the horizontal translation, which we can get from, you might remember, we get from the vertical asymptote. So in the base function, we have a horizontal asymptote at x, in the base function, we have a horizontal asymptote at x equals 0, but in the translated function, we have one at x equals 3. So we can see that the whole graph has been shifted 3 units to the right. So the VA in our base log is at x equals 0. VA transformed is at x equals 3. Therefore, our d value is 3. So there's 1 done nice and simply. Now, to do the rest of it, to help us with the rest of it, there's 2 things I want to keep in mind. And the first is our base log reference points. We've talked about these before, and these are the 2 kind of points, really important points in a base log function that can help you figure out the transformations of the transformed version. And those 2 points in the base log function are the points 1, 0 and 10, 1. Because the exponent you need to put on 1 to get 10 is 0, and the exponent you need to put on 10 to get 10 is 1. So where have those points gone to in our transformed graph? We can see here our point 1, 0 has gone to 3.52. Right, so that kind of key point is kind of halfway through the curve. And the next one, our point 10, 1, has moved to 8.3. And in a question such as this, those points are going to be labeled to help you find them. And another thing we're going to take advantage of, as I told you before, sometimes it can be really difficult to figure out what effect is due to a horizontal change, a horizontal compression, or a horizontal shift, and what change in y values is due to a vertical stretch or from a vertical shift. And there's a little thing we can use to help us out here called the mapping rule. That'll help us figure this out. I'm going to move these out of the way. So the mapping rule tells us if I have a transformed function, how do I map the transformed values from the base values? And what that tells us is you can kind of see it from the transformations of the equation for the transformed, all the transformations for a graph anyway, like in the a log k x minus d plus c. You can kind of see what values or what variables within the transformation of a log function are affecting the x value and what are affecting the y output. So the mapping rule is that the x2, now that is the transformed version. That's the transformed x value compared to the untransformed x value when we're comparing 2 points that have moved, like our reference points here. So our second x value comes from the first x value divided by k and being added to d. Now again, this is a bit more than we'll need to know. I'm not going to ask you one this hard on the exam, but it's good to be familiar with this extra kind of idea. And for the y, the output of y comes from a times the first y value, a y1 plus c. Now let's start with our y values here. I'm just going to highlight these quickly. I'm going to use the base log reference points. Okay, let's start with our y values here. Now the y values in our base log reference points are 0 from 1, 0 and 1 from 10, 1. Now that y value of 0 in our transformed point has become 2. And the y value of 1 in the second point has become 3. Now, we can see here the a value has to be 1. Right, all we're doing in each of these points to go from the untransformed to the transformed is adding 2. There is no multiplying and adding, otherwise our differences between the y values would be different. And you can kind of see that from the graph as well. If we look at the graph of these functions, these first 2 points, here's our transformed version, they're 1 y unit apart. And if we look at our untransformed version, these are also 1 unit apart. If there was any kind of vertical stretch or compression, if there was a vertical stretch, those points would be greater than 1 y unit apart. If there was a vertical compression, they would be closer than 1 unit apart, or less than 1 apart. So we can see here that the a value must be equal to 1. Well, if the a is equal to 1, and we're seeing we're just adding 2, so the c value is 2. And we can double check that by plugging it into our transformation, our mapping rule. So if I wanted to see what the y2 would be if I plugged it in with these a and c values, I'd plug in my y1 value. So I want to see what y2 comes out when I plug in my y1 value. So in this case, let's use the first point, 1, 0. If I put in my y1 value of 0 and added 2, my y2 is going to be 2, and that's consistent with what comes out. And let's test it with the other point as well, just to make sure. Y2 equals, in this case, a value of 1, and in this case, our x1 is 1 in the second point, plus 2 equals 3. So that's consistent with our y values. So we just have a vertical shift up of 2, and no vertical stretch or compression. So you can kind of see that from both the mapping rule and from the graph comparing the transformed to the base function, that there is no vertical stretch. That difference in y values is just due to adding 2 with the c value. Now what about our x values? Well, the x values in our reference points are 1 and 10. Now that 1 value has become 3.5, and the 10 value has become 8. And from the mapping rule, we know that x2 equals x1 over k plus d. Now we know in this case that our d value is 3. We found that earlier from the vertical asymptote, that d is equal to 3. So now I can plug in any of these x1s and x2s and plug in to solve for what k is. So I'm going to pick this one, and I'm going to plug in my x2, my transformed x value is 3.5. My untransformed, my x1 is 1 over k. I'm going to get, subtract 3 from both sides, I'll get 0.5 equals 1 over k, multiply my k over, and then divide by 0.5, and I'll get k equals 2. So those are my transformations there. Let's list them all out as we've now figured it out. We have got our a value is equal to 1, our d value is 3, our k is 2, and our c is 2. We put that all together and we'll get, oh, pardon me, I'm flying up. We'll get y equals log of 2x subtract 3, remember it's x subtract d, plus 2. And that's our final answer.